All right, in this 3.5, which was what we learned on Tuesday, we're going to be factoring by grouping, okay? So we know kind of how to do this because it is one of the steps in factoring that we used to do with quadratics. So you will see that the process is kind of similar to what we were already doing. Factoring by grouping is worksheet 3.5. So let's do some examples here on your worksheet. And the notes I gave in class was very brief. I said always look for, you're going to get a set of 4 terms, okay? It's going to be a set of 4 terms. And I said always group the terms 2 by 2, okay, 2 by 2s. And then you start looking for the GCF every single time between these two terms that you set them as 2 by 2s. So you're always going to be giving 4 terms, and you group them 2 by 2, the first 2 and the last 2. So the first 2 and the last 2. And then you start looking for GCFs between those common terms that you group them. And then you keep on taking GCF out. You might do this more than once, okay, looking for GCF until you completely factored it. And obviously, it's always good to look for difference of 2 squares, okay? And that is what we're always going to be doing here. GCF, difference of squares. Group them 2 by 2 because I gave you 4 terms. Not a trinomial. I gave you 4 terms, okay? All right, so let's take a look at over here how we're going to tackle the situation, see if these notes make any sense. So I said you're going to be given 4 terms. I have an x, that's my first, x plus 2, that's my second, a 3, that's my third term, and x plus 2, that's my fourth term. So I'm going to set them, I'm going to group them 2 by 2s. I'm going to put the first 2 together and the second 2, the last 2 together, okay? Then I look for what both of these couples, both of these terms have in common. Well, this set over here has an x plus 2, and this set over here has an x plus 2. So I'm going to factor out this x plus 2 from both of them. So x plus 2 comes out, and left over we have an x and a positive 3. Okay? So the reason why I could factor them out is because both the first multiplication here and the second, they both had an x plus 2. They had the x plus 2 in common. So I factor out that x plus 2. We started easy for you to see how it's done. A lot of you already know this because it's one of the steps in the factoring, the x factoring method. So you guys are comfortable with that. Let's take a look at one more time. Over here, you set them equal, you group them 2 by 2s. The first 2 product to here goes together, and the second 2 goes together. Now I look at both of them. This product over here of x squared times the quantity of x minus 7, and the second one, negative 4 times x minus 7, they both have an x minus 7 in common. So we factor that out. So x minus 7 comes out, and the leftover, once I divide this by x minus 7, I got an x squared left over. And here, when I factor out by x minus 7, I got a minus 4. Okay, so that looks really good. But again, in my notes that I just wrote it for you, always look for a difference of squares. And this should pop up at you right away. You should see that that is a difference of squares. So we continue factoring. This is x minus 7, and this is going to become x minus 2 and x plus 2. When I multiply a plus 2 and a minus 2 together, I do get a negative 4. When I multiply an x times an x, I do get an x squared. So that is the difference of squares, okay? So now this is completely factored. So always look for GCF and always look for difference of squares. But you said to me in class, Ms. Myers, what happened when they're not the same, when they don't have something common? Sometimes you need to factor out a GCF of negative 1. The GCF is kind of subtle, you don't see it. That's why I want to show number 3. Now I'm going to make it bigger over here because I need more room. So I have 3x times the quantity of x minus 2. That's my first couple right here. But I also have a negative, and I'm going to write that negative 1. It's invisible, but I'm going to make it visible right there. A negative 1 times a 2 minus an x. So when you look at this, you say, well, I'm going to group 2 by 2's, the first two and the second two. But I see that an x minus 2 is not the same as a positive 2 minus an x. They're opposites, actually. Whenever they're opposites like this, if you factor out a negative 1 out of here, if you divide a 2 and a negative x by a negative 1, you'll be able to make this second binomial be the same as the first binomial. So I'm going to repeat my 3x times x minus 2. They stay the same. My negative 1 is the same, but I am going to factor out from here. I'm going to divide both by a negative 1. So I'm going to bring the negative 1 to the front, and I'm going to put the leftover of that division in here. So a 2 divided by a negative 1, it becomes a negative 2. And if I FOIL this back, you would see that I get a positive 2. A negative x divided by a negative 1 becomes a positive x, positive x. And if I FOIL this back, you will see that I would get the exact same term. Okay? So now these two binomials became the same. They're just written in a different order. My x is positive in both of the binomials, and my 2 is negative on both of the binomials. But now I have a double negative 1s here. I just have to clean that up. Okay? So now I have all these three terms here. So we get 3x times x minus 2. But now instead of a negative 1, I'm going to have a negative 1 times negative 1, which is a positive 1. And over here, I'm going to rewrite it. I'm going to keep them the same exact sign, but I'm going to write x because it's positive and negative 2 in the back because it's negative. Okay? I just rewrote the negative 2 and the positive x. And now I made them be the same just by dividing by a negative 1 and extracting that division, that factor, right out. Okay? So now I have the same thing, and I can go ahead and continue with my process. They both have a binomial in common. Let's factor out the x minus 2, the binomial. And if I do that division, if I divide this one by my x minus 2, we get a 3x. And if I divide this other set over here by x minus 2, we get a positive 1 left over. Okay? So there you go. So most of the students, they see that and they conclude the following. They say, oh, so when we have an opposite, all we have to do is factor out a negative 1, multiply by the term that is outside, and then makes it the opposite. So the conclusion is true. You can always factor out a negative 1, make sure that you multiply by the term that is in the front, the value that's in the front, and then you are able to make the binomials be the same. So there you go. We are done factoring this number 5 over here, which will be x minus 2 times 3x plus 1. Okay? So that is just to get you used to factoring groups by grouping, groups of 4. All right, so let's go to something that is not so factored out. This one is halfway done for us to get us used to it. Now let's get one that is from the beginning. Okay? Everything is tangled. We have a polynomial of 4 terms, because that's what I told you at the very beginning. You're going to be given 4 terms. So the first thing you do, according to my notes, was couple them 2 by 2's. The first 2 and the last 2 together. As a matter of fact, I'm going to write it bigger over here. I have a 2x cubed minus a 10x squared minus a 2x plus a 10. Okay, I like it right here. All right, so let's take a look at it. Right there. So we're going to put them 2 by 2's right here and right here. First thing we're going to do, first, look for a GCF. Okay, is the first rule over here. Look for GCF. 2x cubed and minus 10x squared, they both certainly can be divisible by x squared, and 2 and negative 10 can both be divisible by a 2. So I'm going to take out a 2x squared for the first couple over here. Okay, for the first 2 terms. Okay, so let's think about it. If I divide a 2x cubed by a 2x squared, the only thing left over, that division, would be an x. If I divide a negative 10x squared by a 2x, the x squares would become 1, and the negative 10 divided by 2 would become a negative 5. Okay? So hopefully I will make that binomial appear out of my next set of terms over here. So if I look at these 2 values, I can see that a negative 2 can be factored out. immediately I see if I divide this by a negative 2, I would get a positive x, and I know that would work. So I'm going to factor out a negative 2. So let's take a look at the division. A negative 2x divided by a negative 2, which is the factor that's coming out, we get a positive x. A positive 10 divided by a negative 2 becomes a negative 5. So there we go. I was successfully able to make both of this set of terms have a binomial in common. Again, we couple them 2 by 2's. Okay, the first two product and the last two products. And the binomials are common between both of them, so we factor out the x minus 5. If I divide the first two terms, this block everything out, if I divide both of these by x minus 5, the only thing that would result in as an answer would be a 2x squared. And if I divide both of these terms also by my x minus 5, the last thing that would result as an answer would be a negative 2. And then, what did I do wrong here? Because I still, I should have taken a, from the beginning, I should have taken a 2 out. See, even after all these years of doing math, I still don't see a GCF, but there's nothing wrong with it. Here you see that when I stopped, I finished, and I looked at it and said, I can definitely take a 2 out of this. So x minus 5, I should have, from the beginning, and I apologize, I should have seen that a 2, a negative 10, a negative 2, and a 10, they should all be factored out by a 2. Okay? So let me factor out that 2 directly to the front here. And then we would have an x squared minus a 1. And I didn't see that. That's too bad. But at least towards the end, I realized I need to factor out my 2. Okay, now we go 2 times x minus 5, and we see a difference of squares. So we have x minus 1 and x plus 1. So there we go. All right? Hopefully you guys had a better view of GCF from the beginning and taken it out. It would have made our factoring much easier. But that's okay, as long as you recognize somewhere in the middle, oh, I still have something in common that is not okay. Keep on factoring out until you're completely factored out, okay? So good job here. I'm glad I caught that. And the answer for this guy over here would be 2 times x minus 5, and quantity of x minus 1, and quantity of x plus 1. So there we go. All right, let's do one more. Hopefully I'll follow my own rules here and look for a GCF right from the beginning. All right, so let's see. We have a 7 and a 28. That's beautiful. They're both divisible by 7. But 12 is not divisible by 7, and a negative 3 is not divisible by 7. So at least I look for the GCF at the beginning. Now let's couple them 2 by 2. I'm going to rewrite it because I need more room. 7 times c cubed minus 28 c squared plus 12 minus 3c. Okay, let's go over here so there's much more room. All right, so we look for a GCF. I don't see any between all 4 terms. So let's go ahead and couple them 2 by 2's. And even in the middle or towards the end, I'm still going to look for more GCF. Okay, I can totally divide both of these terms by a 7 and also by a c squared. So I'm going to divide by a 7c squared. Let's see what we get from this division. 7c cubed divided by 7c squared is just a c. Negative 28c squared divided by a positive 7c squared, we get a negative 4. Okay, there we go. Then over here, let's see what they both have in common, a positive 3. So let's take out a positive 3. You know what? If I start with a positive 3, I might have to change my mind. I'm going to put a negative 3 and play with it for a little bit. If this was a positive 3, I don't want to write it yet, but this is a positive 3, I would get a positive 4. And that's not what I wanted. I want a negative 4. So I saw that I was going to start with the positive 3, but then I changed my mind because I saw that division would become, if this was positive, it would become a positive. And that's not what I want. So I'm going to stick to negative 3. If I take out a negative 3, then positive 12 divided by negative 3 becomes a negative 4. And that's exactly what I want. And a negative 3c divided by a negative 3 gives me a positive c. So they are exactly the same binomial. They're exactly the same binomial. They're just written in different order. So I am successful here. So let's go ahead and couple them again, the first two and the last two. And let's extract out the GCF, which is the c minus a 4. Okay? So when I divide these two sets over here, these two factors by c minus 4, we get a 7c squared. And over here, these two factors, when I divide it by a c minus 4, we get a negative 3. Let me check to see if I didn't make any mistakes, to see if there's any GCF. Nope, I think we're good here. And 7 and 3 has nothing to divide by, so we're good. There's no difference of squares, and we are done. Okay? So always check GCF and difference of squares. So that is number 13. We have c minus 4 as one of the factors, and 7c squared minus a 3. So there we go. All right, so I hope you can see that the concept is always GCF, GCF, GCF. Look for, group them 2 by 2s and start looking for GCF. If you don't catch in the beginning, hopefully you start catching somewhere in the middle towards the end. I want to do one more problem, which is from the beginning to end. The whole reason why we are factoring things out is because we want to get it completely factored and then graph it. So let's do this one. Hopefully I'm going to try to do all the work in this tiny little space over here. Okay, so the first two terms, the last two terms. I see a 4 and a 16 immediately, and I would love to extract that out, but the first term is not divisible by a 4, so I cannot do that. Okay? Then I think of x's. I can divide this by an x, this one by an x, this one, but the 16 doesn't have it. So GCF at this point does not, all the 4 terms together does not have anything in common. So we're going to go 2 by 2s. Between these two, we can definitely extract out an x squared. Okay, so let's do that division carefully. An x cubed divided by an x squared gives me an x as an answer. And a positive 4 x squared, if I divide it by an x squared here, it gives me a positive 4. Hopefully this exact same binomial will appear here. So let's make sure we divide it by the right thing. If I divide by a negative 4, let's play with negative 4 first. Negative 4x divided by a negative 4 does give me a positive x, and that's what I want from my previous binomial right here. And a negative 16 divided by a negative 4, it does give me a positive 4, so that is beautiful. We made the binomial appear twice, and that's exactly what we want. So I'm going to group the first two factors and the last two factors together, and I'm going to extract out or factor out the binomial that they have in common, x plus 4. Okay, and then we're going to put the leftovers right here. Okay, so this first two factors divide by x plus 4, I have an x squared. And this last two factors divide by an x plus 4, we have a negative 4. And then we have a math eye, so we look for difference of squares right here. So we get an x plus 4, and then that's the binomial that we factor out from the beginning. But for this difference of squares, we also get an x plus 4, an x plus 2 times an x minus 2. A plus 2 multiplied by a negative 2 gives me a negative 4, and x times x gives me an x squared. So I know I factored that correctly. Now let's get the x-intercepts. Okay? When I set each of these factors, every single one of them equal to 0 separately, I'm going to get a negative 4, and I will get a negative 2, and I will get a positive 2. Okay? Now, because the negative 4 only appeared once, I'm going to cross at the x-intercept. Negative 2 only happened once, we also going to cross, and the 2 only happened once, we also going to cross. So there are no bounces. If you go back to your original problem, you see that this is a cubic function. Go back and look at it. It's a cubic function, and it has a positive leading coefficient. So we're going to start low at negative infinity, and you're going to end up high at positive infinity. So I know that that's the general shape of my function. I know I have 3 crosses, so let's go ahead and put those crosses in place. Negative 1, negative 2, negative 3, negative 4 right here, a negative 2 right here, and a positive 2 right here. And that's the shape I'm going to be making. I just need to know what my y-intercept will be, because if I cross here, and then touch somewhere here, and then keep on going up, I need to know that little gap right there. What is my y-intercept going to be? And think about it. It better be a negative number because it's supposed to be down here. So if you go back to your original problem right here, and I'm going to work that out right here for the y-intercept. The y-intercept, I replace every single x with a 0. So I'll have 0 cubed plus 4 0 squared minus 4 times 0 minus 16. 0 cubed is 0, 4 times 0 squared is 0, negative 4 times 0 is also 0, and minus 16. So you end up with 0, 0, 0, you get negative 16. So when I plugged in a 0 for all the x's, we got a negative 16 for y. And that is the work, so you can see our y-intercept is 0, negative 16. So I just come over here and I label, so I know this is negative 16, and let's go all the way to it, and there we go. Okay? So you, on the test and on the quiz, you must label your x-intercept, all right? And you must label your x-intercepts as well so we can see it nicely. So there you go. The whole reason why we're teaching you all this kind of factoring is always because a polynomial can be factored in so many different ways. And besides quartic factoring, quadratic factoring, you have by grouping, and then we're also going to learn by division. So there's many ways of factoring a polynomial according to what the polynomial looks like, the shape of the polynomial, the number of terms we have. So hopefully that was helpful. As you can see, once we're done factoring, the steps stays consistent looking for x-intercept and y-intercept. Okay? So good luck on this worksheet. I hope this helps you, and come and ask for help. I'm always here to help you. Good luck.